For most of history, our species has lived by a simple rule. If you want more of something, you have to put in more of yourself. To double your harvest, you have to double the human hours in the field. Our brains are hardwired for this linear relationship between effort and output. We recently saw the first crack in this rule when we moved into the digital realm. Software and internet platforms allow a single piece of information to be replicated for billions of people at almost zero marginal cost, creating an abundance of media and knowledge that doesn't require a proportional increase in human labor to sustain. This chart contrasts standard linear growth with the sudden compounding nature of an exponential curve. It is the mathematical boundary between physical scarcity and digital abundance. We are currently watching AI cross that boundary, graduating from a tool that lives on a screen to one that can manipulate physical atoms. By applying the rules of digital replication to the physical world, the total productive capacity of human civilization moves from an addition-based economy to a multiplication-based one. Individual creators are now bypassing the traditional bottlenecks of business, like the need to hire and manage massive teams. By deploying AI agents, one person can handle the logistics, research, and execution that used to require an entire department. This network map shows how a single human node can delegate complex parallel tasks to dozens of rapid AI agents. This allows for a 10-day work week, where a month's worth of high-level productivity is compressed into a single calendar block. Operating at this speed requires shifting your role from the person who executes the work to the person who defines the vision. It trades rote labor for a mindset focused on high-level curiosity and clear purpose. Within this structure, a person's daily output is no longer tied to the number of hours they can stay awake, but only by the scale of what they are capable of imagining. That intelligence multiplier is now migrating into physical hardware through the mass production of humanoid robots. Industry projections, cited by Elon Musk and other leading experts in robotics, suggest that by 2040, the Earth will host a workforce of 10 billion humanoid robots, comfortably outnumbering humanity. When robots powered by superintelligence can perform these physical tasks with non-human precision, the economic cost of labor effectively evaporates. The price of getting work done drops to the mere cost of the electricity and the machine's base materials. In this scenario, human physical labor moves from being a requirement for survival to an entirely optional pursuit. If we zoom out to the macro level, we see that Earth's resource constraints are largely a matter of geography. Our planet is finite, but the space surrounding it contains near-infinite energy, metals, and real estate. The barrier to these resources has always been the cost of leaving the planet, but heavy-lift vehicles like the Starship are driving the cost per kilogram to orbit toward $100, making extraterrestrial industry a viable economic model. This schematic shows an O'Neill cylinder, a rotating habitat using centrifugal force for artificial gravity. Built directly in space using materials harvested from asteroids, these cylinders function as self-sustaining ecosystems. They provide habitable zones and agricultural sectors, operating completely independent of Earth's biological limits. This expansion into the space economy serves as a structural solution to the finite bottlenecks of Earth, securing a surplus of raw materials for the long term. All of these multipliers lead to the most finite resource we have, our own biological time. We are beginning to treat biology as a digitizable information technology. This allows for high-resolution diagnostics, like full-body MRIs, to be analyzed by AI at a cost that is rapidly approaching zero. This diagnostic revolution is the engine driving us toward a milestone Ray Kurzweil projects for the year 2033, longevity escape velocity. This chart shows the crossover point where medical progress begins to outpace chronological time. It is the threshold where science adds more than 12 months of life expectancy for every year that you remain alive. By integrating AI with our cellular data, we are moving toward a future where aging is treated as a solvable engineering problem rather than an inevitable decay. The singularity is a continuous technological curve that systematically raises the baseline of human existence. When the input cost for labor, energy, and raw materials all approach zero, the products they create, from calorie production to medical care, become an automated surplus. In this economy, basic food and healthcare are no longer scarce commodities, but effectively free byproducts of an optimized system. As these survival needs are met by default, humanity arrives at a profound psychological split. The first path is that of the consumer. This is a passive existence, where a person allows ambient AI to cater to their base desires and absorbs the automated luxury provided by the system. The second path is that of the creator. This mindset treats AI as a powerful genie, harnessing that intelligence to execute massive, bold ambitions that were previously impossible for a single human to achieve. An era of total abundance is a mathematical certainty, but whether you inhabit that world as a passive consumer or a hyper-creator is the only choice that remains yours.